Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. OK, does electric charge have a mass? E.g., does a charged battery have more mass than a discharged one? That's Kevin from Great Yarmouth.
In theory, a charged battery would have slightly more mass than a discharged one if everything else was exactly the same. Because something which Einstein worked out, sort of getting on for 100 years ago now, is that energy and mass are equivalent. So the more energy something's got, the heavier it is. So if you charge up the battery, you're giving it energy, so it will get ever so slightly heavier. But it gets a minute amount heavier. So if you add 1 joule of energy to something, it will gain 0 with 15 zeros, and then about 0 with 15 zeros, then 1 kilograms of mass. So it's a very, very, very tiny effect. But if everything else is the same, it will be slightly heavier, yes.
All right, let's answer that one then. We've got Dave on the line now from Chelmsford. Hello, Dave.
Good evening, Dr. Dave.
Hello, Dave. Oh, 2 Daves. What's your question, Dave?
Right, the question is, in this day and age, with people getting drunk and doing the most horrendous things, is it not possible that scientists who can do the most marvellous things devise some method that they could put in the alcohol to stop it doing what it does to the brain?
I would have thought, you're drinking quite a lot of alcohol, so you probably need quite a lot of stuff to do anything to it. Your body has various ways of breaking it down, and so you could try and encourage the things which break it down so you get rid of the alcohol faster. I would have thought that even if you could, and I wouldn't say it was beyond the bounds of science to do it, but the problem is that the reason why people drink is to get the effect on their brain. And so if you put something to make alcohol less effective, to have less effect on your brain, I would have thought people would just drink more.
They'd be able to drink, obviously, but it wouldn't do the stupid things that it does to people. And also, the scientists that come up with this would probably be a mega multi-millionaire overnight.
Yeah, I think it would be quite a difficult thing to do. I mean, I guess so. In order to be able to leave it making people feel happy, but stop them getting really, really drunk and falling over.
That's right, and then stabbing and...
Yeah, and getting aggressive. I have seen some research that how people behave when they're drunk is very dependent on their culture. There are some cultures, especially in the Pacific Islands, where when they get drunk, they don't even think, they'd be really surprised that someone got violent when they get drunk, because everyone just gets drunk and sits in the corner and laughs at each other.
Yeah.
And so...
I think I've been there.
Yeah, I think alcohol has a certain effect on your brain, but the aggression, I think it just means that you're slightly... and then the cultural effect is what's making people aggressive. So I think it'd be very hard to separate the kind of making people feel good from the aggression without possibly using an entirely different drug.
But wouldn't it be marvellous if we could?
It would be very useful.
Thanks, Sue.
All right, bless you. Thank you, Dave. Take care, darling.
Take care. Bye.
Okay, bye. Now, Mike in Peterborough says, Dr. Dave, we have on Earth the spectacular northern lights. Could they exist in space? If so, would they be formed in the same way? Mike in Peterborough.
Okay, first of all, the northern lights, they're created when the sun's blowing away little particles, protons, sort of single protons, which are like a hydrogen atom with no electron attached to it. It's helium atoms with fewer electrons, and also electrons are being thrown off as well. And these are thrown out from the sun incredibly fast, thousands and thousands of miles an hour. And they fly out from the sun. And when they reach the Earth, they hit the magnetic field, and they kind of get trapped by the magnetic field. They tend to follow the magnetic field along. And if you've ever seen a picture of a bar magnet near some iron filings, you can sort of see an image of the magnetic field. And so they'll follow those lines into the North and the South Poles. And then these particles, they smash into the atmosphere with lots and lots of energy, and they give the atmosphere energy, and that's released again as light. And so these particles, and then you get sort of changes in how many of them are being sent out, and different changes in the magnetic field. So you get these sort of curtains of these particles hitting the light. They move around and produce beautiful shimmering patterns, which is what we see as the northern lights. So to get an aurora, or the northern or southern lights, you need particles flying out from the sun and then smashing into something. You get that on Earth. I see no reason why you wouldn't get it on other planets. especially if you had all you need is an atmosphere, and probably to get a good one, you want a strong magnetic field to concentrate them all in one place. I know that Jupiter and Saturn have aurorae at their north and south poles because they've been seen by probes and they've been watching them and people study them, so you understand how they work better. But actually in space, there's nothing for them to smash into. You need some gas for them to smash into to give energy, and then it glows. The actual glowing is very similar to a fluorescent light tube or a neon tube. Then the energy's been given to it by electricity rather than particles smashing into it from the sun.
OK. Hello to Jim in Mablethorpe. When the wind is blowing in an easterly direction in the east of the country, why does it usually blow westerly in the other side of the country?
I'm not sure if it usually does. It does. I mean, it does occur quite often, or you can get different wind direction in different places. In order to get winds to change direction, you need something to be pushing them, because if something wants to carry on, everything wants to carry on going in a straight line. You can work this out a few hundred years ago. And in order to change its direction, you've got to push it. And the way you push push air, is by having a different pressure. So if you've got a low pressure area near some air, it will try and move towards that. So if it's moving, it will tend to bend towards the low pressure area. So in order to get in the northern hemisphere, winds go around a low pressure area anti-clockwise. In general, I'd have thought to get, I'm not entirely sure. I've seen a lot of times when you get an entirely different wind direction on the east and west coast.
Dave is working it out.
I'm working it out. I need to draw pictures.
Go on, draw a picture to yourself then. You lightning blowing you. Go on.
Yeah, I mean, you could get a completely opposite wind direction on both sides of the country, but that would basically mean the centre of the low pressure area would have to be almost straight on top of the middle of the country, in which case the wind's going around the low pressure area. So on the west, it'll be going, because the wind tends to circulate at low pressure, it spirals in, and the air gets lifted up in the centre because it's hot and it rises.
Right,
the wind's spiralling in. So if you've got a low pressure area centred on the middle of the country, and on the west it'll be going south, on the east it would be going north.
On the west it'd be going south?
Yeah, it'd be going towards the south, and on the west, so on the east it would be going towards the north.
Right.
I'm having difficulty in my head seeing how you'd manage to get it to go east on the east hand country and west on the west of the country, or from the east or from the west.
I'm totally confused now.
Without having more than one. I think basically you'd have to have quite a complex weather system to be able to achieve it. So I'm afraid I don't know.
Peter in Spalding says, given the present situation with fossil fuels, what is the situation with synthetic variants? I believe the Germans were working on this during World War II. Peter in Spalding.
Yes, the Germans did have a system called the Fischer-Tropsch process, which I think was taking either natural gas or I think probably actually gas you make from coal. So you heat up coal, add water to it, and you get a load of different carbon monoxide and various other things. And they had a chemical process where you could glue the carbon monoxide molecules together and get rid of the oxygen and turn it into a hydrocarbon, which is petrol or diesel. And it probably technology has improved in the last 50, 60 years, and has got a bit more efficient, but it's always going to take quite a lot of energy to convert coal into a hydrocarbon, and that's going to use far more energy and produce far more greenhouse gases than just burning oil straight. There are other ways of getting hold of oil without just pumping it out of the ground. There are tar sands, which you find in Canada. You get billions and billions of tons of... That's like the feedstock for oil. Oil is created when you get organic matter. It goes deep underground, it gets cooked. And then as it gets cooked, the hotter and hotter it gets cooked, the shorter the molecules get broken up into. And so you get oil coming out, and then that oil floats up and gets trapped underneath something, floats on water, because lots of water underground. The oil floats up, it gets trapped, then you can drill down and get it out of that trap.
Texas tea.
Indeed. The oil sands in Canada are sort of that process that's got halfway through. You're in the feed rocks, or when you get very, very thick, sticky oil, which you couldn't pump out because it's much too sticky. So what they do is they just mine it and then break it down a bit and make it make the molecules shorter, which makes the oil runnier. So you can get it out, and you can then chop it up by a process called cracking and turn it into petrol. But again, this uses a lot more energy than just digging it out of the ground straight away, and it's quite a dirty, messy process. So most of the alternatives aren't as good as making oil directly. There are various biofuels options whereby you can basically grow stuff, so that takes in carbon dioxide from the atmosphere, and then you use the organic matter from growing. The Americans are doing a lot by growing maize or corn, and then ferment that and turn it into alcohol, and then you can run a car on alcohol. Or you can grow plants which make lots of oils and convert that into something which behaves very like diesel, and you can run in a diesel car. There's some more advanced systems which are involved either using especially bred algae to produce lots and lots of oil very efficiently, which are much more efficient and produce a lot more energy for the amount of energy you have to put in. And there's also using making ethanol from grass, basically, and just cellulose. So cellulose is in all plants.
Yeah,
and
so the organic thing,
then
it's a kind of natural cycle, but making an artificial...
Yeah, because the problem with maize or sugarcane, it's a very high-quality food crop. And it's actually, for a start, you're reducing the amount of food for people to eat, so food prices go up. And secondary, growing food crops is quite difficult, so it uses lots of energy. So you don't actually get much more energy out than you put in, which isn't really ideal.
Right, Mike in Colchester rang to say, it seems that his car engine runs smoother in heavy rain. Is there anything in this, or is it just his imagination?
There could well be something to it. I don't know about very modern engines, but definitely older engines. It was considered a way in which the cars definitely ran smoother. Mostly because you're injecting a sort of fine mist of little tiny water particles. And then when they get, basically because the air is full of water, and then when they get sucked into the engine, they're going to behave slightly differently. They're going to, when the fuel explodes, they're going to boil this mist of water particles, and they're going to expand. And so you get more expansion, so it could actually produce more power. And also, basically you change the properties of the air slightly. So it will probably change the properties of how the engine works slightly, and I could quite believe that it was running slightly smoother.
Yeah, my Beetle seems to like it when it rains. Yeah, that's air cool. Peter has lived in both hemispheres. He's never checked it, but does the water go down the plug hole, rotate in the opposite direction? And if so, just why?
This is quite an interesting one. It's an old chestnut. There is some good science behind it, but the effect isn't really there. You can get this to work if you get a bath about the size of this room, so about sort of 4 or 5 metres across, make it absolutely perfectly circular, fill it up with water, and then leave it to stand for 2 weeks, and then pull the plug out. And then there will be a minute effect, and because the Earth is spinning, and if you imagine the Earth spinning, if you look at it from the top, if you look at the Earth spinning from the top, it looks like it's going anti-clockwise, and if you look at it from the bottom, it looks like it's going clockwise. The water on the top, as it gets pulled towards the centre, it starts off with a very slight spin because the Earth is spinning. As it gets pulled towards the centre, for a start, when it's on the outside, it's moving slowly and it's got a long way to go. So even if it's moving at sort of a quarter of a mile an hour, when it moves into the centre, that means it'll be going around much quicker because there's less distance for it to travel. Yeah. And as it comes in towards the centre, it gains energy and it spins faster. And so there is an effect there, but it's not one you'll ever see in your bathtub, because it's a minute effect on the scale of a bath or a sink. And what's much, much bigger is exactly how you poured the water in, or how you swirled the water slightly when you got out of the bath, or how the taps put the water into the bath. And those effects will override the one of the Earth itself spinning. But saying that, if you go to a much larger scale, if you go to the scale of the low-pressure areas or hurricanes, then basically because the air is coming in from hundreds or thousands of kilometres, coming into the centre, then there's much bigger effect, there's much more spin. And that's the reason why air circulates around low-pressure areas and why we get so much wind, actually.
We are busy tonight with your questions. Let's say good evening to Dave from Bradwell. How are you?
Hello, so fine, thanks. I'm reading a book at the moment, and he's talking with space travel, about space travel. Now, not all of us know, but the majority of people know that the fastest speed that we know is, 186,000 miles per second, which is speed of light. Yep, this is about right, yeah. Now, this guy is talking about, and can I quote something? It was a movie, but I first read it years ago in a book. It was the Philadelphia Experiment. And I think they were quoting molecular decompression and recomposition, which is something like the Star Trek thing, isn't it?
This is some sort of thing, a bit like a transporter beam or something, whereby you can take something apart in one place and put it back together again somewhere else.
That's what I gathered about it. So what I'm really asking is, do the scientists believe that there is such a thing, or, in fact, do you think there could be such a thing as molecular decomposition and recomposition?
I have some clue. Scientists have been working on this sort of thing. The big problem you get up against is something called the uncertainty principle, which is about what it sounds like.
That's a safety now, yeah, go on.
No, it's not. Scientists understand very precisely about how uncertain things are. It turns out that if you have a particle, you can't know both where it is and how fast it's going. The better you know where it is, the less well you know how fast it's going, and vice versa.
Exactly. Yeah.
Which means that if you can't get you don't know enough, you can never know enough about an object or a molecule, let alone a person, to be able to rebuild an identical version somewhere else. There are some strange quantum mechanical effects called entanglement, which they think you can, by having two identical particles, making one of them bash into something, and then seeing what happens to the other one, you can find out more information than that. And scientists are working on this, and they have managed to teleport things, but they're single photons.
Can I just come in there? I don't know how old you guys are, but I can remember in the very early 1950s, when I was a lad, buying the Eagle comic.
Yeah.
The guy, the space people, and all these whatever, they were talking to people on these picture telephones. Yeah. And here we are now, 50 years down, we've got it.
We've got fertile imaginations here.
Yeah.
Scientists always want it proven, but it does happen.
I would say, that people are working on it, but I think there's an awful lot further to go than there was to get to a mobile phone from where we were in the 1950s, I'm afraid.
Can you remember it, guys? The American warship, Philadelphia Experiment, the ship was partially made invisible, and certain members of the crews, and this is not science fiction, it's a fact, was restored to the ship with parts of their bodies missing. Philadelphia Experience.
I mean, there are ways of making people lose bits of their body without necessarily anything very high-tech going on.
I know,
I don't know. I've read a little bit about the Philadelphia Experiment, and definitely making something out of steel go invisible. I certainly have never heard of anything which could have that effect. And I would have thought that if the Americans had managed to get it to work 50 or 60 years ago, they'd have been building planes out of it, and various people would be finding bombs appearing from nowhere above their heads.
Hang on. Peter has just sent us an email in here saying... he's been saying water injection in engines. The early jet engine used to inject water into the engines to maximise the engine thrust, especially at takeoff or at operating, or when operating at high altitude and extremely hot weather. So at high altitude airports or in extremely hot weather. I believe the Americans still use this method in their tanker aircraft, the KC-135s.
I could quite believe it, yeah, because if you put water into the engine, you've got more gas to expand, and so more stuff to throw out of the back, so you get more thrust. They're
doing everything, the Americans. That's what it is. Dave, you're a star. Bye-bye. Bye-bye. Lastly, we've got Pat from Lowestoft, reference space travel. Hello, Pat.
Hello, Sue.
Hiya.
I'll get this over quick. There's a very famous author who wrote about battles in the air before planes were invented. I was going to lock him up. He also wrote about War of the Worlds. If the Americans had gone to Mars, they could come across somebody far more advanced than what we are, and Mr. Wells' book might be true.
Yeah, I mean, that's always a possibility. Although we've got pretty good, they'd have to be hiding very well on Mars for them to fight. They'd have to be they'd be hiding very, very well because we've got very good pictures of Mars now. So I was talking to a scientist who studies Mars who was on the show last weekend, and she was saying that you can actually get much better photos of Mars free on the internet than you can of Earth these days.
I think it's great the way everything's remained. You know, they've been up there for so long, those little robots and stuff, and they're still there. Obviously, very advanced with their power packs and everything they've got on there.
Yeah, I mean, they're solar powered.
Yeah.
And in fact, a big problem they have is that because they're getting the energy from the sun, and Mars, although there's a very weak atmosphere, it's about 1% of the Earth's atmosphere, there's still quite high winds, and it blows dust around. And they have a big problem that the dust keeps landing on top of their solar panels, and so it builds up and builds up and builds up, and dust isn't very transparent, so they're getting less and less light into the solar panels.
I wanted to ask you, actually, about wind turbines, because if I made one,
yeah.
Right, just say, if I just made one, how do you connect it into the grid of your own home power supply so you cut down your electricity bills? That's what I want to know.
OK, so you've got a wind turbine, the wind blows, it turns the turbine round, and you've got a generator attached to it, which you spin a magnet near some coils, and that generates electricity. Well, I have to make one of those as well. You have to build a generator as well. Just making something spin, I'm afraid, won't produce you electricity.
Right, OK.
And then you need a very clever piece of electronics to convert the electricity from the generator and feed it into the grid. Yeah. Because it's got to be 240 volts, and because mains electricity is alternating current going backwards and forwards, you've got to make it alternate in exactly the same speed as the mains electricity, otherwise it can cause all sorts of havoc. And so basically it's an expensive piece of high-tech electronics, and plugs it into your mains, and you've got power coming.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.